Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video, let us continue the discussion with our earlier probability distribution. That is, we were discussing regarding normal distribution. So, normal distribution is also referred as Gaussian distribution. Normal distribution, the graph or else the curve, it looked like a bell-shaped curve, isn't it? We have studied all these things in the previous video. And also we came to know that this normal distribution is indicated with the probability density function f of x. What is that particular formula? The formula is f of x is equivalent to 1 by sigma square root of 2 pi into e to the power minus 1 by 2 into x minus mu by sigma whole square, where the value of x, it can range between it will be greater than or equal to minus infinity, and it will be less than or equal to plus infinity, isn't it? We have studied this. And also, what is the sigma value? Always the sigma value will be greater than 0. Yes, and also we know that this normal distribution will be having two parameters. What are those two parameters? The parameters of normal distribution are, one is mu, that is mean. Mu is nothing but mean, can also be referred as expectation of x. Okay, that is mean. And followed by what is another parameter? The another parameter is sigma. This is nothing but standard deviation. Okay, so normal distribution will be having how many parameters? Will be having two parameters, mu and sigma. Mu is nothing but mean and sigma is nothing but standard deviation. So in today's video, let us study about a very important rule. Okay, that rule is called as the rule is referred as 68 95 99.7 rule. Okay, this is a very important rule. So usually this rule is referred as 68 95 99.7 rule. Okay, so what is this rule? So already we know that a variate, let us say x is a variate. So this variate will be referred as a normal variate with parameter mu and sigma. How it is denoted? It will be denoted as normal variate. X will be denoted as a normal variate. X will be denoted as a normal variate with mu and sigma square. So this normal variate x will be having two parameters. The parameters are, one is mu and another parameter is sigma. Sigma is the standard deviation, mu is a mean. So, okay, so but usually for our problem's sake we will be representing like this. X is a normal distribution with it will be having parameters mu and sigma square. What is sigma square? It is nothing but variance. Okay, here. Fine. Later, now we will be studying the area. What will be the area and how this area will be distributed? That is, how this area within this curve will be distributed. That will be studied here in this particular video. Okay, so that is area property of normal distribution. So we will be studying area property of normal distribution. So what is that area property of normal distribution? Please notice here. So in why we will be using these graphs or else charts? What is the use of them? So that we can take up an addition at a faster rate. In case if the data are plainly represented in tables or else plainly they are in text type, they won't convey much of the thing. So in order to understand them in a better way, we will be representing them either in a two-dimensional chart or else graphically we will be representing them. So the same thing here also, we will be representing the data in a graph. What type of curve we will be using? It will be a bell-shaped curve, also called as a normal curve, also called a probability curve. Okay, so please notice here. Let us say that we have visited a particular school or a class having 50 students. After visiting these 50 students, we have measured their heights. Their mean height is let us say 5.5 feet. Okay, their mean, the average weight, that is x bar, is the complete population x bar is weight, mean average is height is 5.5 feet. Similarly, what is the standard deviation from one boy to another boy, or else from one person to another person? What is the change in the height? Let us say there is a change in the height is 0.5 feet. This is the change. This is the standard deviation. Okay, so how many students or how many people we are visiting? We are visiting around 50 students, and we have collected their data regarding height. So mean height of all the students is 5.5 feet, and what is the standard deviation? The standard deviation is, that is deviation from the average, is 0.5 feet. Okay, so now we need to plot it in a two-dimensional graph. Okay, how to plot it? Please notice here. Please consider. Let me write a bell-shaped curve. Okay, so here the central point, it indicates, the central point indicates mu. What is mu? Mu is nothing but mean or median or mode. All of them, they sit at one particular point. Okay, so this is mean. So what is the mean height? The mean height is 5.5 feet. And what is the deviation? How much deviation is there? The deviation of only 0.5 feet. So that is towards the right side. If we move towards the right side, 0.5, if you add 0.5 to this, then it will be 6 feet. And let us say, okay, let me consider here, somewhere here, it is 6 feet. Okay, from here it is 6.5 feet. So here 7 feet, and it goes on. Similarly, towards the other side, that is the lower side of the mean value or median value, it is here 5.5. It is, let us say, somewhere here 5 feet. Okay, and here it is 4.5 feet, and it is here 4 feet, and it continues. So here, this complete area from 5 to 6, this is one standard deviation. This is what? One standard deviation. So what is this 68, 95 and 99.7 rule? What is this rule? It says that if you study the height of these 50 students, for example, for my example, I can see 50 students. If you study them, almost 68% of them come within the first standard deviation, that is like this. Okay, so this is the area, this is 0.68, or else you can also represent them as 68%. So nothing but in the population of 50 students, 68% of them, their height comes within one standard deviation. Okay, so towards the negative axis, that is minus standard deviation 0.5, towards positive standard deviation 0.5 is there. So that is one standard deviation. So within this area, you will be finding 68% of them are fitting in with this one standard deviation. So if you go on both the axes another 0.5 standard deviations, then let us say this area up till here. Okay, so this area, it indicates 95% of them, that is 0.95% of them cover this area, that is the 95% of which will cover 2 standard deviation. Nothing but out of 50 students height, 95% of them will come in this particular area. Similarly, if you go again 0.5 standard deviation on both the axes, both the side of the axis, then this area, this is 99.7%. Okay, so what is the total area under the curve? The total area is unit. Okay, that is 1 or 100%. Always it is 1 or 100. You can represent it in 1 area is 1, or you can represent it as 100%. Okay. So, usually the total probability will be 1, or you can represent it as 100%. So, what does it mean? If you consider a population, if the population, if let us say is 100%, and 68% of them will be within the 1 standard deviation, 95% of them will fall in 2 standard deviation, and 99.7% will fall in 3 standard deviation. So, that is how we are going to represent them. So, if this is the center is mu, the center is mu, then towards the right side of the mu, that is mean or median, it is mu plus sigma. On towards the left side, it is mu minus sigma. This is 1 standard deviation. If you increase it, next mu plus 2 sigma, towards lower end here, it is mu minus 2 sigma. Again, this is 2 standard deviation. This is 2 standard deviation. Next, this area is, this particular point is mu plus 3 sigma, and here it is mu minus 3 sigma. Okay. So, what we were studying in this particular video, we were studying the area property of the normal distribution, how the area will be covered, how it is distributed. How it is distributed? It is divided into this ratio, that is 68 is to 95 is to 99.7. That is out of in the complete population, 98% of the 68% of them will fall in 1 standard deviation, 95% of them will fall in within 2 standard deviation, and 99.7% of them will fall in 3 standard deviation. And what about rest of them? What is the rest? The rest is, that is the area below this area. Please, you can observe here, both the tiles, both the end of the tiles, they are not going to meet the x-axis anyway. They will be moving up till infinity, both in negative infinity as well as in positive infinity direction. So, what is this area? This area is just a very small area, 0.3%. 0.3% will fall under both the ends of the tail of the curve. Okay. So, this is a very important topic that will be discussed in all MCQs. Okay. So, with this I am going to end the video. Thank you.